Welcome back, Focus Learners. Today on The Explainer, we are channeling our absolute best academic coach energy because we're about to conquer the comprehensive Grade 9 Math Big Test Review packet. We're taking a massive amount of mathematical information and basically turning it into a highly structured visual masterclass. So grab your notes, get focused, and let's get ready to crush this review. Okay, first things first, let's talk about the stakes here. This test, it's worth 15% of your final mark. Now, before your heart rate spikes, seriously, take a deep breath. There is absolutely no need to panic. If you follow this guide and just engage with the material, you're going to be more than ready. We're breaking this 15% down into totally manageable, bite-sized pieces. Here's our roadmap for today. We'll start with the test day playbook, move into mastering numbers and polynomials, hit solving for the unknown, explore shapes, spaces, and geometry, and wrap it all up with real-world math applications. All right, Section 1, the Test Day Playbook. Look, before we even touch a single equation, we need to review these physical essentials from your packet. You got to bring a calculator, a pencil, a water bottle, and a snack, and definitely your EQAO formula sheet. I literally cannot stress this enough as your coach. Being practically prepared dramatically reduces test anxiety. When your physical needs are met and your tools are ready to go, your brain is entirely freed up to just focus on the numbers. And that brings us to the absolute most important piece of advice pulled directly from the review sheet: confidence in what you know. Bring that confidence with you. You've done the work, you've studied the formulas, and having a strong, positive, focused mindset, that is the ultimate test day essential. Okay, let's dive into this. Section 2, mastering numbers and polynomials. First up, we need to quickly get our fundamental number set straight. On the left, we've got natural numbers. Think of these as your everyday counting numbers starting at 1, 2, 3, and so on. Now, contrast that with integers on the right. These include 0 and the negative numbers, stretching endlessly in both directions, like -5, 0, and +5. Knowing exactly which set of numbers a question is asking for is a vital building block for, well, the whole shebang on this test. Once you know your numbers, you really need to know how to maneuver them. Consider this sequence for dealing with polynomials. Say you've got an expression like 5x plus 3 plus 7x minus 2. We just follow a structured problem-solving approach. Step 1, expand using the distributive property. You multiply that 5 by the x and the 5 by the 3, which gives you 5x plus 15. Then, step 2, collect your like terms. You combine that 5x with the 7x to get 12x, and combine the positive 15 and negative 2 to get a positive 13. Just like that, your messy expression beautifully transforms into a clean 12x plus 13. Moving right along to Section 3, solving for the unknown. Now we're leveling up from simple expressions into algebra and linear relations. And this brilliantly illustrates how we actually identify different types of slopes visually. Look at these 3 examples from the source material. The first one shows a line climbing upward from left to right. That's your classic positive slope. The middle one, even though it's way steeper, is also climbing, so it's another positive slope. But look at that last one. The line is falling from left to right, which means a negative slope. And hey, if the line were perfectly flat and horizontal, you'd be looking at a 0 slope. Getting this visual shortcut down will save you massive amounts of time on test day. But how does this actually look off the grid? Let's ground these linear relations in reality with what I like to call the plumber's equation. From the review packet, a plumber charges a $50 surcharge plus $65 an hour. This translates perfectly to the equation y equals 65x plus 50. The $50 is your y-intercept. It's the flat fee you pay before any work even begins. The $65 is your slope. That's the variable rate multiplied by x, which represents the number of hours worked. This is exactly how the classic y equals mx plus b equation operates out there in the real world. All right, on to Section 4, shapes, spaces, and geometry. Stepping straight into the physical world now, take a look at this right-angled triangle. We know the vertical side is 7 centimeters, and the long diagonal side, the hypotenuse, is 26 centimeters. To find that missing bottom base, we just apply the Pythagorean theorem, which is a formula you will be provided with: a squared plus b squared equals c squared. By plugging in our knowns, you can algebraically solve for that missing side. You literally just let the formula do the heavy lifting for you. Geometry also takes us into full 3D space. Here we have a cone, and it's mapped out with a radius of 2.4 centimeters and a height of 4.7 centimeters. And again, don't sweat it. You don't need to memorize the volume formula for a cone. It's right there on your EQLO sheet. Your job is simply to correctly identify these 2 dimensions on the visual, carefully plug the 2.4 in for the radius and the 4.7 in for the height, and just calculate.
Now, speaking of the radius, let's pull in a really key foundational concept from our Maths Alpha source. They define the radius of a circle, denoted by an r, as the line from the center to the edge. So why does this matter? Well, because a circle has a ton of physical parts. Chords, tangents, arcs, and circle theorems exist simply to connect these physical parts mathematically using angle relationships. Understanding these basic definitions, that's exactly what allows you to unlock those super complex geometric puzzles.
Let's move to and see how this builds into Section 5, Real-World Math Applications. This right here is the final boss level, answering that classic student question, when will I actually ever use this? Well, you're going to use it when you're dealing with your money. This concept contrasts two absolutely crucial financial terms from the review: depreciation versus appreciation. Imagine you buy an $840 computer. The packet tells us it has a depreciation rate of 2% per week. Basically, it's rapidly losing value. Contrast that with a $1,500 piece of fine art that appreciates, increasing its value by 7.5% every year. Understanding how to calculate these percentages literally dictates whether you are losing money over time or growing wealth. Let's look at another super relatable example, Daria's car fund. So Daria wants a $7,995 Jetta. She brings in $520.25 a month in net income. Pretty good, right? But wait, she has expenses. $11.29 for Spotify, $110 for cafeteria lunches, plus her phone bill. When we actually subtract her variable and fixed expenses from her income, we find out how much she's actually saving. By doing the math, it turns out those cafeteria lunches and that Spotify habit mean it's going to take Daria 29 long months to finally buy that car. It's kind of like a gentle reality check, courtesy of grade 9 math. Now, what's really interesting about this slide is how we apply math to real-world trends. Look at this scatterplot comparing sunglasses sold on the x-axis against ice cream sales on the y-axis. You can clearly see a line of best fit pointing upward. It's a strong, positive correlation. Basically, as one variable goes up, the other goes up. And when we look at the raw data for this, we can start making estimates. If we estimate how much ice cream is sold when 200 sunglasses are bought, we're looking inside our existing data range. That's called interpolation. But if we want to predict how many sunglasses are sold when ice cream sales hit a massive $650, we are guessing far outside our plotted dots. That is called extrapolation. And while it's useful, it definitely comes with a much higher margin of error. So the crucial point is, does buying a pair of sunglasses magically make you crave a scoop of vanilla ice cream? Of course not. This highlights a massive real-world rule. Correlation does not equal causation. Both of these items spike because of a hidden third variable, hot summer weather. Math shows us the pattern, but logic explains the why. Which brings us to our final big takeaway. From calculating compound interest on your savings, to measuring the square footage of your room, to interpreting the hidden variables in data trends, math doesn't just help you pass a grade 9 test. It empowers you to read the underlying structure of the real world. Master this review packet, use these tools, and you won't just ace the exam, you'll gain a skill set for life. So as you walk into that exam room, ask yourself, are you just solving for X, or are you learning to decode the matrix around you? We'll catch you on the next explainer.